The best way to use this video is to think of it as a test for yourself, kind of a practice test. Pause the video after reading each problem, then work out your solution to the problem, and continue the video to check your solution. If you need more examples of any of the problems you're having trouble with, remember to look at your ebook and to look at the notes you've taken when you've watched videos. Let's start with some finance questions. Find the simple interest on a $1,500 loan for 2 months at 10.5%. Pause the video and see what answer you get. We'll use a simple interest formula to find the answer. The principal is $1,500. The interest rate, written as a decimal, is 0.105, and the time is 2/12 because 2 months is 2/12 of a year. When we multiply and round to the nearest cent, we get $26.25. On June 1st, you purchased 10 shares of a stock for $60. 6 months later, the shares were worth $80. What was the percent increase in the value of the shares? Pause the video and try to find the solution. For percent of change, we need to first of all find the change in the value. There was a $20 difference in price from the original price to the new price. Then to find the percent of change, the percent increase for this problem, we need to take that change in value and divide it by the original price, which was $60. As a decimal, that's a repeating decimal, 0.333. And if we write that as a percent, it's 33 1/3%. Now let's try an APR problem. James purchased a new computer for $1,200. He made a $200 down payment and financed the rest with a 24-month loan. His monthly payments were $45.50. What was the amount financed? What was the finance charge? And what was the APR for the loan? Pause the video and see if you can answer these questions. The amount financed is the amount that he borrowed, which was the $1,200 price of the computer minus the $200 down payment. So he financed $1,000. The finance charge is the interest that he paid. We'll have to first of all look at how much total money he paid back to the bank. Over 24 months, he paid 24 times $45.50, or $1,092. Of that $1,092, $1,000 was the amount he financed. The rest is the interest, or the finance charge. So the finance charge is $1,092 minus $1,000, or $92. To use the APR table, we need to find the finance charge per $100 of amount financed. We find that by taking the finance charge and dividing it by the amount financed, the $92 divided by the $1,000, and then multiply that times 100 to get 9.2 or $9.20 interest for every $100 financed. Now back to the table, and we'll focus on the 24 payment line because he made monthly payments in a 24-month loan. In that line, we'll find the number that's the closest we can get to $9.20, which is this one, $9.09. Reading up from there, we can find the annual percentage rate, the APR, which is 8.5%. Andrea took out an $8,000 federal student loan at the start of her freshman year of college. The interest rate on the loan was 5.5%. Find the monthly interest amount rounded to the nearest cent for a 30-day month. Pause the video and work the problem out yourself. We'll use the daily interest formula to find the interest for 1 day. That's the balance of $8,000 times the interest rate written as a decimal, 0.055, divided by 365.25. That gives us a very long decimal number for daily interest. Don't round that number because we're going to use it to find the amount of interest in a 30-day month. which is 30 times that daily interest. Once you've done that multiplication, you can go ahead and round to the nearest cent, which is $36.14. Now let's move on to sets. For the set A, containing the elements A, B, and C, how many subsets does set A have, and how many proper subsets does set A have? Pause the video and find the solution. The number of subsets is 2 raised to the power, which is the number of elements the set has. So 2 to the third power is 8 subsets. For proper subsets, we can't count the set itself as being a proper subset. So we take that 2 to the third subsets and subtract the one subset that is equal to the original set to get 7 proper subsets. For this question, the universal set consists of the letters A, B, C, D, and E. Set A consists of A, C, and E. Set B consists of elements C, A, and B. Which elements are in set A prime intersect B complement? Let's pause the video and see what solution you get. Let's break down the statement. We'll start with A complement, which is everything not in A that is in the universal set. That's the elements B and D. We also need to take that set and intersect it with B. So A complement intersect B consists of all the elements that are in A complement and also in set B, which is only B. Finally, we need to find the complement of that set. That set consists of all the elements in the universal set that are not in A complement intersect B, which is the elements A, C, D, and E. Now let's try a Venn diagram problem. 70 people were surveyed about the restaurants they have eaten at in the past year. 16 ate at Applebee's, 24 ate at Burger King, 20 ate at Chili's, 9 ate at Applebee's and Burger King, 11 ate at Burger King and Chili's, 7 ate at Applebee's and Chili's, and 2 ate at all 3 restaurants. How many people ate at exactly one of the restaurants, and how many people ate at least 2 of the restaurants? Pause the video and find a solution. We'll start with the 2 that ate at all 3 restaurants. That means where the 3 circles intersect, there have to be 2 people. Working up from there, we know that 7 ate at Applebee's and Chili's. So where circles A and C, A for Applebee's, C for Chili's, where circles A and C intersect, we have to have a total of 7 people. We already have 2 in that intersection, so another 5 have to be in this part of the Venn diagram to make a total of 7 in that intersection. 11 ate at Burger King and Chili's, so where circles B and C intersect, we have to have a total of 11. There's already 2 in that intersection, so the other 9 have to be in this part of the diagram. 9 ate at Applebee's and Burger King, so where circles A and B intersect, there have to be a total of 9. We already have 2 in that intersection, so another 7 have to be in this part of the Venn diagram. 20 ate at Chili's, so in the entire C circle, C for Chili's, we have to have 20. We've already got 5 plus 2 plus 9, that's 16 in that circle, so there's another 4 in this part of the diagram. 24 ate at Burger King. That means in the entire B circle, we have to have 24. We already have 7 plus 9 plus 2, which is 18 in that part of the diagram. So another 6 would have to be here to give us 24 in the entire B circle. 16 ate at Applebee's, so in the entire A circle, there have to be 16. We already have 7 plus 2 plus 5, which is 14 in the A circle, so we need another 2. And then finally, in the entire Venn diagram, we have to have 70, because 70 people were surveyed. If we add together the 2, the 7, the 6, the 5, the 2, the 9, and the 4, we get 35, which means there's another 35 people that didn't eat at any of the restaurants. So now to answer the first question, how many people ate at exactly one of the restaurants? We're looking at the diagram for any part of it where only one circle is covering that part of the diagram. That's where the 2 is, the 6, and the 4. If we add those numbers together, we get 12. And for the second question, how many people ate at least 2 of the restaurants? We need to find every part of the diagram where 2 circles are crossing. That's the 5, the 9, and the 7. And because it says at least 2, that also includes where 3 circles cross, which is the 2. And if we add those numbers together, we get 23 people. Now let's move on to some logic questions. Write the contrapositive of the statement, if I studied every day, then I passed the exam. Pause the video and come up with a solution. If our original statement is if P then Q, the contrapositive of that is if not Q, then not P. For this sentence, the P is I studied every day. It's the part after the if. And the Q is I passed the exam. That's the part after the then. So the contrapositive would be if I didn't pass the exam, then I didn't study every day. Given P is true, Q is false, and R is false, find the truth value of this compound statement. Pause the video and see if you can come up with a solution. One approach could be to make an entire truth table for this compound statement. We don't really need to do that though, because we're only interested in the truth value of this statement for 3 specific values of P, Q, and R. So rather than making an entire truth table, let's take this compound statement and substitute for the P, Q, and R the truth values that we know. So we know that P is true, Q is false, and R is false. So we'll substitute true and false in for each of those letters, depending upon what values we were told for this particular problem. Now let's keep simplifying. First of all, I notice not true in the first set of parentheses, and not true is false. So let's change the not true to a false. Now let's find the truth values for what we see in the parentheses. In the first set of parentheses, if false, then false is true. And in the second set of parentheses, if true, then false is false. Finally, we have to evaluate if true, then false, which is false. So the truth value of the compound statement is false. Determine whether the statement is a tautology, a self-contradiction, or neither by constructing a truth table. What are the truth values in the solutions column, and which of those 3 things do we consider the statement? Pause the video and come up with a solution. So let's construct our truth table. We need to come up with some columns that we can use to build this statement. We'll need a column for P and Q. We'll need a column for not P, and then we'll need a column for our entire statement. In the first column, P and Q is only true when both P and Q are true. So that means we have true, false, false, and false. For the second column, not P is the opposite of P. So we'll just negate everything that we see in that first P column to get our not P column. And finally, for our solutions column, we have an if-then statement, which is true unless the if part is true and the then part is false, which means the first row is false and the rest of them are true. So our solutions column is false, true, 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 and that means that the statement is neither a tautology nor a self-contradiction. If all of those were true in the solutions column, we'd have a tautology. If all of them were false, we'd have a self-contradiction. Now let's look at a logical argument. Construct a truth table for the argument, then determine whether the argument is valid. We'll let P be I went to grad school, and we'll let Q be I got a full-time job. So our logical argument is, if I don't go to grad school, then I'll get a full-time job. I went to grad school, therefore I didn't get a full-time job. We'd like to know what the solutions column is and whether the argument is valid or not valid. Pause the video and come up with a solution. Our first step is to write this logical argument using symbols. We already know what P and Q stand for, so we'll take this sentence by sentence. If I don't go to grad school, then I'll get a full-time job is written as if not P, then Q. I went to grad school is written as P, and therefore I didn't get a full-time job is written as therefore not Q. Now to put that together as one statement, we have to say the first premise and the second premise will lead to our conclusion. So if we have the first premise and the second premise, then we have our conclusion. Now let's build our truth table. We'll have to take the pieces of that statement apart so that we can put them back together again. We will need a not P column. We'll need an if not P, then Q column. We'll need a column for our two premises put together with an and. We'll need a not Q column, that's our conclusion. And then we'll need a column for the entire logical argument. In our first column, not P is just the opposite of P. Our next column, if not P and Q, is only false when not P is true and Q is false. So that gives us true, 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 and false. Our next column puts our two premises together with the and. So we have true, true, false, and false. Our next column is the negation of Q, which is false, true, false, true. And finally, we have our solutions column. So our second to last column is our if column. The column right before our last column is our then column. So we're looking at those two columns, which are only going to give us something false if we have if true then false. And we do have that in the first row and true everywhere else. So our solutions column is false, true, true, true. If we have all trues, then our argument's valid. If we have any falses in that solutions column, our argument's not valid or invalid.